Uh, good evening, sir. So now let me welcome Padhee, sir, the speaker of our second session. So Mr. Prabodh Ranjan Padhee, a former Chief General Manager, Rourkela Steel Plant, Steel Authority of India Limited, is a mechanical engineer, graduated from Regional Engineering College, presently known as National Institute of Technology, Rourkela, in the year 1980. After that, sir has joined as management trainee technical in SAIL in the same year in November 1980. He has worked in various capacities, have his experience in maintenance area of rolling mills projects, concept to commissioning of slab caster, and finally operation and maintenance in the steel making, which includes BOF converters, secondary metallurgy, and slab caster. He has worked as a head of the Department of Steel Meeting shop at Rourkela Steel Plant. He has also worked 2 years in senior management leadership role as Chief General Manager of Refractory Department dealing with refractory of entire plant of Rourkela Steel Plant. Sir has completed 18 modules of Harvard Management Mentor of Harvard Business Publishing. USA completed 2 days Assessment Development Center program at MTI Ranchi and that was conducted by KPMG and completed various senior management program conducted by SAIL. Sir is author of non-fiction bestseller book titled The Vision of a Middle Class Man and co-author of the technical book titled Process Modeling for Steel Industry. His area of expertise in training and workshops are primary steel making, secondary steel making, continuous casting, refractory engineering, advanced maintenance management, and skill. He is having 4 granted patents into his credit. He has also published 7 articles in international journals. He has academic association with NIT Rourkela, NIT Raipur, Biju Patnaik University of Technology. He has presented various papers in national and international conferences of these institutes. He is also a consultant of waste to energy in renewable energy sector and consultant to social impact sector with a special emphasis to sustainable development goals laid down by United Nations. I welcome you, sir, in this ATAL online 6 days faculty development program on clean energy and environmental sustainability. Thank you, sir.
Thank you, Professor Sharma. Thank
Thank
you, all professors and audience present here. I am really grateful and delighted that I have been given the opportunity to speak. Basically, I am not from academics, but I am from industry. But subsequently, right before I superannuated, I had always the interest because I strongly believe that industry and academia relationship should be very strong so that our nation building will be much better. In that concept, I published certain papers and I worked in the field and tried to, corroborate that in the academics. And I found that it yielded very fantastic results. That's why I could publish 7 articles, as said by Professor Sharma.
Yes,
and I wrote a book with professors of NIT Rourkela, which is process modeling for steel industry.
Yes, sir.
And the other one is my passion, which I write. I'm a writer basically. So that is regarding my traveling spree all over the globe.
Yes,
so
sir.
this is what I have been doing. And after superannuation, I thought that I should not be working for any company. And I'm a freelance consultant, a corporate trainer, and you can say partially academician. I am not a full-fledged academician, but I take a lot of interest in my alma mater, which is NIT Rourkela.
Yes.
And I keep on visiting and discussing with professors.
Yes, sir.
So this is what I do. So let me directly share my screen because my topic today, which I have been given, is I'll be talking on sustainability, climate change, and its mitigation. It will be a generic thing that I'm going to talk. It is not very specific, but I would start that. And let me tell you that this will start from, very rudimentary stage. Then we'll go into the subject deep into it, right?
Dr. Mulli, can you make a co-host to Padhee, sir? Dr. Mulli?
Yes, sir. Yes, sir.
Yes.
So, is it visible?
No, sir. Right now,
No, sir. No,
Yes,
sir.
sir.
Not right
So
now.
now,
Yes, sir. Now share your screen, sir.
I was sharing my screen actually. Share your screen. Okay. Entire screen. Share.
Entire screen, sir. Yeah.
Is it visible?
No,
No,
sir.
sir.
Arey.
Yes, sir. Now it is showing,
Yes,
sir.
yes,
Yes,
Now
sir.
it's showing. Na?
Yes, sir.
So you can see the whole screen or
Yes.
No, sir. Make it full screen, sir.
full screen. Okay. Just 1
Yes,
second.
sir.
Slideshow, sir.
Yes, sir. Currently, sir,
I'll just do it.
economic growth.
Is it okay?
Yes, sir. Yes, sir. Fine, sir.
Now it
Yes,
is
sir.
full.
Yes.
Okay. So, respected professors and faculties, as I believe some students are also there, and various intellectual forum. I am really delighted again, and I'll be just talking about sustainability. With regard to sustainability, let us discuss what it is. So, if you really see, before 700 BC, we know what we have already talked about sustainability, which is called Vasudevaha Kutumbakam. So, in Mahaupanishad, in 700 BC, it has already been mentioned. So, it is really not a very new subject that we are talking today, but it has been very, very relevant now because the world is going in such a manner that we have to discuss about climate change, sustainable development, and at the same time, peace and tolerance. These subjects are extremely important to bring a harmony and see that the sustainability all over the globe exists. Now, I have changed my screen. Is it okay? Hello?
Yes, sir.
It is visible? Okay,
Yes,
thank
sir.
you. Thank you so much.
Yes, yes.
So, hence,
Is good, sir.
sustainability is very far from a new concept. That's why I'm saying. So, the natural environment and its limit and the cycles and changes, these have to be taken into consideration. So, what are the things that we should look into? The people that we the people, then the planet, the animals, the natural phenomena, the landscape, timing of events in a specific ecosystem. So we have to see that there is a ecosystem is balanced properly. So that is what is actually sustainability. So what are those things? As we all know, it is space, fire, air, water, and earth. So we have to bring a balance about all these 5 elements which exist. So as we all know, 5 elements of the nature are Prithvi, earth, Jal, we all drink every day, without that we cannot survive. Tejas, fire, we need heat. Vayu, the wind and air. Akash, that is space. All these things are inevitable right from 700 BC, as I said, it has already been mentioned. So we have to look into these things and bring a harmony so that how every element of this nature does not really get decayed or does not perish. So in this present context, the sustainability is, the meaning is meeting the need of the present without compromising the ability of future generation to meet their own needs. What it means is the way we are depleting or exhausting our resources, if we go on doing that, then probably our children and grandchildren, at least mine, will, they will not leave me. They'll say, they'll curse me. So that is why it is very prudent that meeting the needs of the present without compromising the ability of future generation to meet their own needs. This is a fundamental definition of sustainability in the present context. So there are 3 dimensions of sustainability, as I said already. So how? By fulfilling simultaneously the 3 essential pillars. What are the pillars? The environmental protection that we are talking about these days, and it is very, very relevant. Then the social development, and then economic growth. All the 3 areas have to be really discussed. Now, what does this sustainability implies again? Let us see. So, sustainability is assuming that the nature and the environment are not an inexhaustible source of resource, but subject to protection and rational use. We cannot simply waste water. We have been, there are, so in the ministry level also, water conservation, Ministry of Water Conservation, Ministry of, renewable energy. Why these things are coming? Because we have already exhausted to such an extent, we have been exhausting. So there has to be a break somewhere, and we have to see that our future gets resources and they use it gainfully further, so that we can have a harmony in the entire world. And to be very specific, at least in our country, we must see. So factor like environmental conservation, a commitment to renewable energy, saving water, incentivizing mobility, that is whatever vehicles and other things. I was just listening to the previous professor about, I think he was talking about biofuel, particularly on diesel. And it's a very important thing, because the mobility, we are using vehicles and even many other IC engines or compression ignition engines, all are running through diesel. So that was a very prudent subject, which I was just listening the fag end of the discussion which was going on. Then sustainable fashion. Fashion means we have to wear such things that it should be biodegradable. Mostly we should try to see that. Then innovation in construction and sustainable architecture. All these things are coming in sustainable environmental, how we can conserve the environment. What are the social impact? Social impact is quality of life, healthcare, and education. So the cohesion among the communities and culture. There are diverse culture and diverse community in all over the globe, as well as in India. And we have to see that there is a cohesion which exists. So the fight for gender equality is another aspect. So we must believe and nurture the gender equality. That is also social development. Then economic growth. Thirdly, the sustainability also drives economic growth, generating equitable wealth for everyone without harming the environment. That means somebody would be very, very rich and the other would not be getting food to eat. Such a economic growth does not have much meaning. So now you are seeing, we all call sometimes, I don't want to get into politics, but if you really see, there are certain schemes which are coming these days to see that the downtrodden people, how they will get even at least food, the ration, whatever, every day we need, those are being given. So, and the have and have not, there are two categories. So there should be some rationality in it. That is the true economic growth. So now for the economic growth, the challenges like climate change and water scarcity can only be resolved at the global level and by prompting sustainable development. Now we know that the essence of sustainability, hence the only solution is act in the present, think for the future. So immediately we have to act. There is no time for us to, you cannot delay the process. So let us go to some report or some concept which was actually brought in by in the globe. That is, first one was published in Brundtland report. Brundtland report is basically from Norway. The Norwegian Prime Minister, he had thought about this sustainability and particularly climate change. So there was a report which was published in 1987, also called Our Common Future. The Brundtland report published by the United Nations. The United Nations thought that it is very, very relevant and they also published it. It was the first to warn of the negative environment consequences of economic development and globalization. That means if you only see the economic growth compromising the environment, then there is no point. So that growth is actually negative. Okay. So the report attempted to offer solutions to problems emerging from industrialization and population growth. Now, when these things were being seen, that why this concept as you know, which is coming, that the Brundtland report came at the same time. In US Army in 1987, a concept came which is called VUCA. VUCA is volatility, uncertainty, complexity, and chaotic and ambiguous. Now the whole world is moving towards that more and more. So there is a lot of volatility and everything is uncertain. Today, for last few days, you must be listening about the news that some outbreak is there in China again. Nothing to worry about it. Our government is very prompt and has been taking a lot of actions on that. But this is what is called uncertainty and complexity. The things are getting more and more complex. Now AI and ML have come. And as you know, everything is automated, robotics, all these things. So ambiguous. So many people are looking at it, whether is it genuine or are we going in the right path or not. So that is why it is a bit ambiguous. So the VUCA concept was again brought in by Herbert Barber. He published the article after the breaking of USSR and East Bloc. As you know, when USSR, Union of Soviet Republic, and it got disbanded, as you know, and even now there is a war between Russia and this Ukraine. So these things, when it came into these things came into picture. So this concept VUCA actually came, and this gentleman Barber published an article on this. Now let us come to our subject gradually, which is the Sustainable Development Goals. After having known this Brundtland report and these development which came, Barber wrote up in 1991, then everybody became very alert. United Nations took a very prompt action, but it was in 1st January 2016 that 17 Sustainable Development Goals were spelled out. And this has been the mandate for all over the world, and they named it as 2030 Agenda for Sustainable Development. So we will primarily focus on two areas because our topic is primarily on sustainability, then climate change, and also is mitigation. So we will focus on affordable and clean energy and climate action. So Sustainable Development Goal 7 and 13 we will focus. So let's focus on 13 and 7. So the climate action and clean energy. So what is the major source of climate change? The major source of climate change is the greenhouse. You all are intellectuals. All of you rather know what is the greenhouse, but we must bit in detail, we should know about it. So this greenhouse is nothing but it is constitutes of carbon dioxide and methane, nitrous oxide, and all fluorides, that constitute 3.1%. So primarily carbon dioxide and methane. So once we go detail how it is generated, where it is impacted and all, you will all be able to know. So carbon dioxide enters the atmosphere through burning fossil fuel. That we all know. The coal, natural gas and oil. Once we burn it, the carbon dioxide gets emitted. Methane also is emitted during the production and transport of coal, natural gas, oil. Methane is also the result from livestock. Okay. Even methane is also generated from our agricultural waste and even biodegradable waste. If you just throw it outside, methane is also generated. Then nitrous oxide. The nitrous oxide actually one of the major contributor is diesel engines. Just now our professor was talking about it. So let us, we all know about it also. So the shoots which come out, which is in, this in Delhi, you must be knowing that how people suffer because of the vehicle pollution. And vehicle pollution, the shoots which come out from the diesel engine, which is of, we are more concerned about 2.5 micron. And that is what creates havoc. So nitrous oxide is also another problematic area. then fluorinated gases. So all these constitute especially the greenhouse. So with global warming potential, GWP that typically range from thousands to 10,000, they are sometimes referred to as high GWP gases because for a given amount of mass, they trap this substantially more heat is generated. So the greenhouse effect, how it is actually impacted? How it impacted? Due to the first and second industrial revolution, the greenhouse gas increased exponentially. See, we started our industrial revolution thinking that, yes, we have to go for industry, we have to have economic growth, but we without bothering what will be the consequence. And subsequently, if you really see, the era began in 1760 with the use of coal, which is the fossil fuel, which was the most abundantly available. Then electricity, second revolution, industrial revolution also started happening. So from 1760 till date, we went on using fossil fuel, we are still using, and we are creating more greenhouse gas and impacting the whole universe. So the fossil fuel is a very typically dangerous thing, but it is inevitable for us, though there are one of the best dust catchers are being used by NTPC, by SAIL, Steel Authority. We are also trying to go for green, green steel. Those detail I will not go today. But the fossil fuel burning has to be rationalized at some manner. So regular movement, then agricultural deforestation. Deforestation is also another very big impact. Livestock and other changes in land use of account for about 25% of the atherogenic greenhouse gas emission. So just imagine, suppose, as we all know, because of photosynthesis, the plants, they get their food, and incidentally, they take carbon dioxide and emit oxygen. And it is always better to get oxygen for human being. So what a fallacy. That means, suppose we keep on cutting forest, we are actually harming so much so. That is why government has brought so many rules that if you cut one tree, you have to plant 5 trees now. Previously, it was 2 trees. So rules are there. Because unless we really, believe in it and we really nurture about it, then we cannot stop this greenhouse effect. Then the industrial processes, livestock, all those things also are the major contributor. Just see, I have captured one, statistics. Highest is, China. Top greenhouse gas emitters in 2018-19. China, then United States, then European Union. India is 4th, if you really see. Then Russia, then Japan, Brazil. So these are the contributors. And coincidentally, China and United States are much more, and European Union than us. Then cumulative emission in 1760 to 2017. What is 1760? When we started our first industrial revolution, when we started burning the fossil fuel, brought the steam engine. We all know that even our railways were run by steam engine. James Watt started the steam engine. We all know about it. So this is what has happened over about 300 to 400 years. Okay, almost 300 years. So United States is the highest, again, impacted highest cumulative emission. Then European Union. But India is the last in that. So we have really not contributed too much so far as the whole world is concerned. Now, greenhouse gas increase after revolution 1 and 2, as I already said, in around 300 years, the percentage increase of greenhouse, that is CO2 by 30% has increased. And CH4, that is methane, has increased by 100%. That means it has become double. So when things have become double, you just imagine how difficult it is now to precipitate those CH4 and neutralize it. Similarly, carbon dioxide. And typically, as you know, CH4, that is methane, is lighter than air, whereas carbon dioxide is higher, heavier than air. So how it sinks and how it is precipitated, we'll discuss in our further slides. So the global warming and climate change, this has already we are seeing, and it has become very alarming. So the whole world is now looking at it. The greenhouse gas trap heat from the sun in the Earth's atmosphere, causing global warming, which is, we all know. So greenhouse gases absorb the sun's heat that radiates from Earth's surface and trap in the atmosphere. So this is all for the human activity also it happens. So global warming is causing the Earth to warm faster than ever before, which is leading to change in weather patterns, rising sea levels, and disruption in natural habitats. This is what we are seeing. I will give you certain examples what is happening after these slides. So greenhouse gases are trapped in the lower atmosphere, which is around 8 to 14 kilometers higher from the Earth's surface. Okay. At an altitude of 5 to 6 kilometers, the concentration of greenhouse gases is so low that it can escape to space. But unfortunately, it is not able to escape, because beyond that, we have created an envelope, and that envelope is actually obstructing the heat or the greenhouse gas to be dispensed with. So here are some other things to know about greenhouse gas. So what is happening? The ozone layer, as you all know, acts as a greenhouse gas at the top of the troposphere, and troposphere is about 19 to 20 kilometers higher from the Earth's surface. However, ozone is in the stratosphere, which is about 48 to 50 kilometers higher. So obviously, it definitely helps us in our when the sun emits what we call our bodies, and we know that ozone layer and other things, ozone depletion, but this is what is actually happening, which is not getting absorbed. So what are the absorbent for carbon dioxide and methane? That also we'll discuss in detail in our next slides. So the water vapor, carbon dioxide, all these things, as we have been talking. So the natural cycle of now, why greenhouse gases are so dangerous? Because the natural cycle of absorption of carbon dioxide, which is the major contributor in getting disturbed, as it takes about 150 to 200 years to absorb in the ocean, grassland, etc. That means the natural sink, which is actually the sea and the plants, forest, the natural sink we have destroyed. And typically carbon dioxide gets absorbed. It takes very, very long time, 150 to 200 years. Methane takes quite a less time, 5 to 7 years. This is a point to be noted, because this is extremely important that we must understand how promptly we have to act so that there should not be any harm to our future generation. So the tree, all these things actually in research published in the Nature in 2024 shows that upland trees remove methane from the atmosphere. This discovery reinforces the importance of trees and forest for the climate system. So there has been many research papers which I have referred, and you will find that even methane is also absorbed. I'll come to that. So what is carbon sink? Let us understand what is carbon sink, how the carbon dioxide and methane can be absorbed. So a natural carbon sink is a system that absorbs more carbon dioxide from the atmosphere than it releases. That is what is called carbon sink. What are the carbon sink? The forest. Trees and plants absorb CO2 through photosynthesis, that I have already told you just now. The second one is ocean. The ocean absorbs CO2 through photosynthesis in the marine vegetation and physical process like dissolution in seawater. See, the carbon dioxide has got a nature to get dissolved in water, seawater, because our sea is 70% and land is 30%. So that is a major source of heat, a carbon sink. But it has also got a potential. Then grassland. Grassland contributes to soil organic matter, which is stored in their root mats. The roots itself actually absorbs a lot of carbon dioxide. So the global atmosphere methane uptake by upland tree woody surface. This article you can see even it is published. So this was published in July 24, and the source is Nature volumes. You can see in this slide. It is very clear that how I have also taken the abstract, and I'll just read the only headline, main portion of it, because you can go through this journal and you can see it's an open access journal. You can see. So we find that methane uptake on woody surface, in particular, at and above about 2 meters above the forest floor, can dominate the net ecosystem contribution of trees, resulting in a net tree methane sink. So just imagine, even the bottom portion of the tree, that means the woody surface, not the leaf, it also absorbs methane. That is a research in 2024 July. So why carbon sink is so important? Carbon sinks are important in the fight against climate change because they help reduce the amount of carbon dioxide in the atmosphere. So to help combat climate change, we need to reduce our dependence on fossil fuel and transition to renewable energy. That is the reason why we have to go to gradually renewable energy. So we can protect and preserve existing carbon sink and plant new forest or restore destroyed forest. So that is why we, this NGT, National Green Tribunal, they are so strict. When you go for an industry, we think that they are actually troubling us, but they are doing their job because they are seeing the future. And we have to see all these things, that how afforestation and is so important. So how long will it take the temperature to stop rising or return to normal if we stop emitting greenhouse? Suppose today you stop emitting greenhouse, which is really, I'm saying it is actually not possible because suddenly you cannot stop greenhouse emission. Suppose, say for instance, we stop. So about 50% of carbon dioxide increase will be removed from the atmosphere within 30 years. That means from now, it will take 30 years to, suppose we stop today the greenhouse emission, it will take 30 years. Only 50% of the emission, that greenhouse, will be reduced. Further 30% will be removed within a few centuries. The remaining 20% may stay in the atmosphere for many thousand years. This has been taken, I have taken from US Greenhouse Gas Inventory Report. Okay. So the scientific consensus is clear that to stop further climate change, humanity must stop adding greenhouse gases like carbon dioxide and methane to the atmosphere. This is very, very clear. Okay. So the good news is that the reversal could begin quite quickly, says Andrei Sokolov. Sokolov is a very big scientist, and he has published a lot of reports on this. A climate modeler working at the MIT Joint Program on Science and Policy of Global Change. So this gentleman, he is from MIT, and they are really doing research on how we can really mitigate the climate change through what are the sources and what we should do so that mitigation can really take place. So in 2020, Slovako was a part of the team that studied a variety of scenarios in which carbon dioxide emission stop entirely in the near future. Suppose it stops. So in the most of the models used in their simulations, average global temperature stops rising after a couple of decades, but says above the historical average for many centuries. It means that when we started the industrial revolution, at that time, what was the normal temperature for which there was no melting of sea? There were North Pole and South Pole was full of ice. All these things have been destroyed gradually. To go to that normal, it is virtually, as of now, is not possible, because we have destroyed so much that it is just not possible. However, a few models showed continued warming for decades or even centuries after the end of carbon dioxide emission, but they were in the minority. So there are a lot of, when the scientists discuss, there is always a difference of opinion. So we are still continuing on how long will it take. So I am just trying to give you ignite your mind, so that we, as an individual, as an engineer, as a technocrat, as a scientist, we must work towards this. That is why I am trying to emphasize all this subject. So Sokolov also cited one plan, that the study model called Sky 2050, which was meant to keep the planet from warming by more than 1.5 degrees Celsius. So under this scenario, humans sees all climate pollution in 2030, and the average global temperature decreased right away. So it will start decreasing. And as you know, even in India, I'll come to those slides also, we all have agreed to a simple policy that by 2030, we will do this. But what are those things? I will come in detail in my next slides. So yet temperature falls so slowly that the earth cools by only half a degree Celsius by the end of 21st century. That means 21st century completion, even after it is completed, it will be cooled only by 0.5 degree. Okay. So now the ocean is the most crucial piece here, as it takes in a huge amount of carbon dioxide from the atmosphere and has absorbed 90% of the heat from the recent decades warming. Okay. Some of the carbon is mixed from the shallow ocean into the deep ocean, where eventually turns into rock. That has already happened. It was happening also earlier. We were not knowing, because we, as I showed you one slide, the 30% carbon dioxide has already increased, and 100% methane has already increased in the whole world. How to sink it? That is the problem. So, but carbon mixing into the deep ocean is a very slow process. This scientist from MIT says. So, how long will it take? Again, it is a very big subject. So, but to know exactly how long, whether a return to normal would happen in the year 2300 or in the year 300, requires use of a sophisticated type of climate model called an Earth system model. So they have already started working, and even in India, we have also started discussing with those scientists. And ESM, which simulates biological activity in ocean, forest, and other ecosystem, that is ESM. There is Earth system model. It's a model. So these models are computationally demanding that most of the today's long-term climate solutions use only simplified ESM. So now we are using the simplified ones. But some scientists are already working on the long-term, how we can really stop this particular thing. That's why the Earth system model has already started. So these models, that's why I'm saying, you really need to model with the real ocean, and it will take forever to run it for a few thousand years. As you know, the knowns above the atmosphere is many and unknowns are less. And it is just contrary for the sea. More unknowns, but less of knowns. So that is the typicality of something happening in the sea. And unfortunately, the sea is the biggest sink for carbon dioxide and to a great extent also methane. So this is the source is MIT Climate, December 19, 2023. You can refer this also. So what is the consequence? What is happening now? Extreme climate conditions. You are seeing that sometimes it is so chilling that we are not able to, control. And sometimes it is so difficult for us to even floods are happening in India and landslides. All these things are happening because of this only. So what are the examples? Melting of ice, rise in level of sea, severe floods in Spain. Recently, you might have known that in Spain, flood was a very rare thing. But in a place called, there's Valencia, severe flood was there in Spain. And Valencia, the sea beach and all the place got embedded totally. Bomb cyclone in North America. Bomb cyclone is when the temperature, the pressure drops within 24 hours to 24 millibar. 1000 millibar is 1 bar. So if it drops by 24 millibar, then there is a vacuum which is created. And in the cold condition, when already there are ice or froths, that starts moving in a very high velocity. And what happens is the consequence is, you might have heard in US, particularly in the West Zone and, West Coast and East Coast, we call it. West Coast is California and other area and San Diego and all. This side is Washington and your New York and all. That area, for the bomb cyclone, the temperature 40, minus 35, minus 40, what happens is your pipes get frozen, okay? And it gets burst because, as you know, when something becomes ice, the volume increases. The pipe get burst. So this is what is now happening. And the worst scenario, in the recent past, you must have heard in October 2024, there was a heavy drought in Africa, particularly Namibia and Zimbabwe, where we are conserving the animals. This particular country were forced to kill animals, okay, and feed their people, feed their human being. So about 700 animals were killed in Namibia, and about 100 elephants were killed in Zimbabwe, only to feed to the human being that you might be knowing. So this is the consequence of climate change. So how we can mitigate? Now let us come to the mitigation plan. Efforts to reduce emission and enhance sinks are referred to as a mitigation. There's a fundamental broad sense. As I have already explained you about the sink. What are the sinks? The way we call in thermodynamics heat sink. Here it is carbon dioxide sink, methane sink. Okay. This is what I wanted to explain you. So effort to reduce emission and enhance sinks are referred to as mitigation. Mitigation is nothing but scientifically, this is what I am showing you. So the conservation requires all pillars, keeping in mind their responsibilities, capabilities, and to formulate, implement programs containing measures to mitigate climate change. In a one day, we cannot do all these things. So every country, including India, we have started a lot of things. So the United Nations has several climate change mitigation plans, including the Paris Agreement, the UN Secretariat Climate Action Plan, Global Environment Facility. So Paris Agreement started in 2015, and UN Secretariat, this action plan also is there. The Global Environment Facility, GEF, all these programs have already been started, and lot of talk are still going on, and how it is helping each country. I'll get into that. I'll just show you. So the climate change mitigation, the only solution is carbon neutral world. Okay. carbon neutral, I'll explain you in the further slides, but let me tell you, COP26 or the 26th conference on the parties was the 2021 United Nations Climate Change Conference. There was a United Nations conference in 2021 where they call it COP26. That was the 26th conference. That was a very vital one. When and where? The conference was held in October 31st, November 13, 2021 at the SEC Center in Glasgow, Scotland. Okay. So what happened in this Glasgow Climate Pact, which included agreements to accelerate action to reduce carbon dioxide emission by 45% to reach net zero around mid-century, and phase down coal power and phase out inefficient fossil fuel subsidies. So climate change mitigation is still being continued. Now the United Nations framework convention on climate change, that is UNFCCC, which has a membership of 197 countries. So 197 countries have already united, where India is also there, and has a global mandate to address the climate change. But the major body is GEF, that is Global Environment Facility. Okay. So this policy, to mitigate this, what are the policy? Policy, regulatory approaches, financial mechanism, institutional capability or capacity, innovations. We have to go for a lot of innovation, private sector engagement, international cooperation, information dissemination. Today, what we are doing is, at least we are passing the information, and I am really glad and delighted such a prudent subject has been chosen by our Government Engineering College, Palatu. I am really delighted. And within 6 days, a lot of things will be discussed. I was seeing the subject matter and the professors who are talking on this subject. This is what actually information dissemination, Unless we know what is happening, how can we think of mitigating it? So climate change mitigation still continuing. So what are the key thematic area of these projects? Renewable energy, energy efficiency, green financing. I'll explain what are these. Enabling activities, transparency, global impact program in cities, and mobility. Mobility means, as you know, whether it is your motorcycle or four-wheeler or a truck or a ship in the sea, whatever. So we will slightly go faster. Then at 9:15, I think we'll stop. Then you will be asking whatever questions you have. So Professor Sharma, is it okay if I finish by 9?
Yes, sir. Yes, sir. Yes, sir. We are here, sir. You can finish by your own time, sir. No issue, sir.
Okay. Because after that, at least 10 minutes should be there for interaction, Only
yes, sir. Yes, sir.
It's not proper. Okay.
Yes, sir. Sir, topic is very interesting, sir. We all are enjoying, sir. You can continue, sir.
Okay. So through this expertise and regional presence in Africa, Asia, Europe, Latin America, everywhere it is now present. And various governments and diverse parties are working to implement a portfolio of $280 billion worth of GF. As I said, GF is the main body. They are controlling the global environment benefits. So we all are, now I'll come to carbon neutrality and net zero. We all talk about net zero. You all must have heard also, many of you must be knowing. But what is net zero actually? Net zero emission is when the amount of greenhouse gas emitted by human activity is equal to the amount removed from the atmosphere. It means, suppose you are burning 1 ton of fossil fuel, say for instance. Let us take an example. That fossil fuel, say for instance, out of 1 ton of fossil fuel, you are generating, say, 100 meter cube of carbon dioxide. So whether that carbon dioxide is getting into the sink, it is becoming zero, or it is going to the atmosphere, again adding the carbon dioxide, whatever is already existing in abundance or more than requirement. So, and even methane for that matter. So the net zero means you cannot further add. Whatever is there. Whatever processes you are doing in the world, in the industry or otherwise, you cannot add any further more, this greenhouse. That is what is called net zero. That means we cannot stop industry, we cannot stop living. We cannot stop our vehicle to be run. And I was listening very carefully about, somebody was asking about lithium battery vehicles have already come, and whether is it worth going for battery vehicles. See, there is no other way out, because the research is still going on, and the professor also said that research is still going on. It's absolutely correct. The heavy metals, mining is difficult, we all know. But the heavy metals, batteries made out of that. We can't help it. So these things will happen, and there will be solutions to it, because the research is going on in a very fast pace in the world now. So removing emission, removing carbon from the atmosphere through natural approaches like restoring forest or technologies. We have to see now, whenever we are talking, there has been 3 conferences in 3 years in Rourkela Steel Plant, which fortunately I had one of my colleagues presented a paper also, the green steel, on the green steel. So everywhere now green steel is being told about. Okay, not only green steel, green anything green in any industry for that matter. So net zero is important because it helps in limit global warming. Okay. So there was a Paris Agreement, 2 degree, 3 degree, let us forget it, that will go on happening. So net zero is a state where the amount of greenhouse gas emitted by human activity is balanced by amount removed from the atmosphere. Net zero is an internationally agreed upon goal to mitigate global warming. So this is what is net zero. So how we achieve it actually? As I said, reducing emission, removing emission, reduce emission, and also you do remove emission. So removing CO2 from the atmosphere by planting trees, which absorb CO2 and release oxygen. This is the biggest thing that we can do, or easiest thing rather. In your campus also, don't forget, every inch of your campus, please plant, trees. That will help. You may not be realizing. That is why everybody is saying, no deforestation, please, plant trees. Important. Net zero is important because it's a state which global warming can stop. Okay. Then what is carbon neutrality? I had told in the previous slide. So carbon neutrality means having a balance between emitting carbon and absorbing carbon from the atmosphere in the carbon sink. That is what is carbon neutrality. So in a nutshell, in order to achieve the net zero emission, all worldwide greenhouse gas GHG emission will have to be counterbalanced by carbon synchronization. So net zero is similar to carbon neutrality. Please listen it carefully. So net zero is similar to carbon neutrality, but is expanded in scale. That means carbon neutrality, if you are talking in a micro level, net zero, we are talking in a macro level. You got my point? So carbon neutrality generally includes a wider definition of offsetting reducible emission and would not prescribe a specific reduction trajectory. That means if you are generating this type of carbon dioxide or methane, you have to do this much reduction. It doesn't say that. It's a broader sense. Okay. What is carbon offsetting again? So another way to reduce emission and pursue carbon neutrality is to offset emission made in one sector by reducing them somewhere else. It means, as I said, suppose green steel, green aluminum, or whatever green you talk about. When we are, say for instance, in the steel industry perspective, because I have spent whole my life in steel industry, so I can tell. Now suppose in coke ovens, we have got stamp charging and many other new concepts where we really we capture the whole gas and we convert it to mixed gas. It goes from blast furnace, SMS, as well as coke ovens, and these gases are actually having very high calorific value of 4,200 kilocalorie per kg. It is used as a fuel, so we are not trying to capture as much as possible, and carbon dioxide or even carbon monoxide also is emitted. I'm not talking about that. So these are the way that we are actually trying to offset the carbon. That means by using one energy, you are reducing another energy, and you are gainfully using that energy to do another job. That is what is called carbon offsetting. Okay. So the European Union emission trading system is an example of a carbon offsetting system. So the European Union were very intelligent. They started in 2005, this ETS, carbon trading. So the European Union emission trading is a market-based system that aims to reduce greenhouse gas emission in the European Union and other countries. How it works? The European Union ETS amount the greenhouse gas emission that certain sector can produce. All sector actually does not necessarily emit carbon dioxide or carbon monoxide. Okay. So it then allows polluters to buy and sell permits called EU allowances to emit greenhouse gas. Each EUA gives the holder the right to emit greenhouse gas equivalent to 1 ton of carbon dioxide. The EU reduces the number of EUA available each year to meet its climate goal. You got my point? That means when an industry is established or going for modernization, or a new industry is coming up, they have to declare that we are going to this much of greenhouse we are going to emit, and they'll be given license for that. That's all. Then they will be given a target that annually you have to reduce this amount. That is how the carbon trading works, and for that they'll be getting some bonus. So EU emission trading system still continues. So electricity and heat generation, industrial manufacturing, aviation, and maritime transport. As I said, maritime transport is a very big area actually. We do not perceive that. Even the defense, even the normal maritime ship movements, most of the things in the world actually moves in the water. If you have seen Germany River Rhine, or even River Seine in France, they are one of the biggest, transporter of their articles from one place A to place B. Okay, so the European Union ETS is intended to help European Union to meet its climate goal, which include a 55% reduction in greenhouse gas emission by 2030 and net zero emission by 2050. So when it started, as I said, this trading started in 2005. Okay. So they are the European Union is the first union or the combination of countries who started this. So what is carbon credit? Carbon credit is a certificate that represents a reduction or removal of carbon dioxide or other greenhouse gases from the atmosphere. Carbon credits are measured in tons of carbon dioxide equivalent, TCOE2. So carbon credits are bought and sold on carbon market, which are trading system that allow companies and individuals to compensate for their greenhouse gas emission. So if an industry or anybody who is actually emitting the carbon dioxide or greenhouse, they'll be given a certificate or a credit certificate rather, that if you eliminate or reduce this much, you will be benefited by this, whether it is financial term, or you can go for more production, or other ways. And more production is, directly proportional to money. So that is how it is working these days. It is a sort of incentive, I should say. So example of carbon credit. Carbon credit can be generated through projects that take in carbon from the atmosphere, such as reforestation, renewable energy project. How many renewable energy projects you have taken? That also is being monitored very, very minutely and closely. Use of technology, that is hoover up carbon dioxide. So the United Nations Carbon Offset Platform issues carbon credit, which can be purchased to compensate for emission or support the projects. So if you want to take a project, you can take, this money. And I had shown 150 or 160 billion dollar I showed you in this particular project. It is there. So people are using that. Even India is also using in many areas. So some facts about India. Let us know about what India is doing. India's power demand and capacity are projected to increase significantly in the coming years. So what is the 2026-27? The projected peak electricity demand is 277 gigawatt, 0.2 gigawatt. And the electrical energy requirement is 1907.8 BU. So 2031-32 mein kya hota hai? What is happening? The projected peak electricity demand 366.4. 247 mein 708. See, it is almost getting, if not doubled, almost doubled. Okay. So this is how our requirement is for the expansion or the economic growth. If you really see in India, we want this type of exponential increase in electricity, but we cannot further use fossil fuel. So 2050, India plans to nearly double its power capacity to 900 gigawatt, up from the current 425 gigawatt. India's total energy consumption per capita reached to 0.8 TOE this ton in 2023, which is half of the Asian average. So we have to further go in electricity, but that electricity or that power, that generation should be through renewable energy. So what is TOE? TOE, or ton of oil equivalent, is a unit of energy that measures the amount of energy released when 1 ton of crude oil is burnt. It is a normalized unit. Just for explanation, there is a normalized unit. Here are some equivalent amounts of energy in tow. 1 TOE is equal to 11.6 megawatt hour. 1 TOE equal to 1,800 gigajoules. Like that. These are all the equivalents. So the country's top energy sources are thermal energy, 65%, hydroelectric, 25%, nuclear, 3%. Alternative means whether it is solar, biomass, whether you call it biomethanation, whether you call whatever. Everything together only 10%. Okay. So this 10% again will further segregate. So as of October 24, this is the latest. I have taken the data. As of October 2024, India's renewable energy installed capacity was 203.3 gigawatt. Okay. So this gigawatt is including large hydropower also, because that is also a renewable energy basically. So wind power is 47.71 gigawatt. Solar power is the highest, 92, and we are really going exponentially in solar power, particularly semi-arid land and arid land. We can really do it faster where the sun is always there. And biomass, fortunately, India being a tropical country, we have really are doing well in solar. Biomass and cogeneration, that is 10.72. Small hydropower. This is also come to a concept. Even one of our professor in Biju Patna University, he is doing some research on this. He has already published a paper. And we had a discussion about 2 months back on this subject. So waste to energy. This is where I am a consultant. Waste to energy. We are using minimum. So we must focus on this. Large hydropower, 46.96 gigawatt. Okay. So what is the mitigation plan? Roadmap in India 2030 decarbonization target. India's decarbonization target act, that is COP26, which I told you, that is the 26th meeting of Paris Agreement. India has agreed for 2030 decarbonization target was announced. The highly ambitious goal includes decarbonizing energy to 50% and achieving 500 gigawatt of fossil fuel free generation capacity by 2030. So this is what our target is. Just imagine. We don't have time. Today it is already where 2025 has started. Only 5 years. India has set a target to reduce the carbon intensity of the nation's economy by less than 48% by the end of decade. So achieve 50% of cumulative electric power installed by 2030 from renewables. That means whatever is there, 50% cumulative electric power has to be there from, your renewable energy. Then only we can achieve net zero carbon emission by 2070. So India's aim to provide 5 million tons of green hydrogen by 2030. Green hydrogen also we have started thinking. This will be supported by 125 gigawatt of renewable energy capacity. So 50 solar park with an aggregate capacity of 37.949 gigawatt has been approved. Wind energy has an offshore target of 30 gigawatt by 2030 with the potential sites identified. See why I'm saying this. When we have COP26, we have already agreed, and India has an optimistic plan of 50% generation by renewable energy. These are the data and statistics that we have to install. And government is giving so much of subsidy, you cannot imagine. Because one of my friend, a junior friend, who is working on solar, I am also, you can say, associated. And Tata Power has got collaborated with that, and government is giving heavy subsidy for your solar rooftop, this solar power. So Indian Exchange, IEX, India's premier power exchange that provides nationwide automated. We have already got a national grid, That is why green energy is also being renewable. It is a renewable energy, green energy. And we are also certificates are being issued even in India. In September 2024, IEX traded 723 million units of green energy and 224% year-to-year increase. That means we have been doing quite well so far as the green energy is concerned. And it is also connected to, now on-grid also has started. Suppose you are having surplus, you can give it to the grid. I'll give an example just after a few slides. So National Green Hydrogen Mission, it is launched in 2022, developed a green hydrogen production capacity from 5 million metric tons per annum by 2030 at about 125 gigawatt renewable energy capacity. So these are the plans that India has. It's a very good and optimistic plan, and we can really leverage through industry-academia relationship. And when Australia, I was just seeing an article, reading an article, I have not put it here. Now they have put strips, they have already developed, it has not been commercialized. We are seeing the panels, okay? Instead of panel, it's a roll, and that roll is a strip form. That you simply put it somewhere, wherever the sun is coming, and it will absorb, heat, and it will photovoltaic effect, as you know, it converts electricity from the cells. So the strip itself will generate electricity. So these are the new development which are going on, and very soon, within a year or so, it will be commercialized. So why not in India, and why not the institutes like yours or ours can join hand and really do research on renewable energy. So renewable energy trading involves the trade of electricity produced using renewable means and other renewable energy commodities like biofuel. Okay. So solar power, hydropower, wind power, geothermal power, and bioenergy, which is biofuel, all these things are, as you know, these are our way to improve solar power in India. Improve solar panel efficiency, that we all talk about, and there has been a lot of research going on. Now, the thickness has already gone down of the solar panel, and the dimension for, say, for 1 kilowatt, say, for instance, per kilowatt surface area has also got reduced. So research is continuously going on. So advanced solar power technology, then develop battery storage solutions. Thermal storage, you might be knowing. I am not going to talk too much into technical thing, because that itself is a subject. I can talk on that, particularly waste to energy and to a great extent to solar. But because of paucity of time, and there are many areas which may not be able to be discussed in detail. However, so improve transmission infrastructure. As electrical engineer must be knowing that in India, the transmission loss is about 27 to 30%. So how to improve that? That is also coming under the renewable energy sector, because renewable energy is also connected to grid. So there is a common grid. It is not different than fossil fuel grid. Okay. The other one, hydel, which we have. So off-grid solar power. So this is how a solar panel and wind energy looks like, which we are improving day by day in our country. And if you have gone anybody to Rajasthan, this scenery, this I have actually taken in Rajasthan, particularly when you go from Jodhpur to Jaisalmer, or Jaisalmer to the dunes, sand dunes, you'll find beautiful such things. So this is the principle. You all know electron flow and hole flow, photons, N-type silicon. These all are made out of silicon, as you know, P-type silicon. And the load, this is the load, bulb is glowing. So this is just a schematic that I wanted to show you. And how solar energy is converted to electricity, that most of you are knowing. I need not have to read all this thing. So primarily it is a photovoltaic effect, which is called. You can go through that and see. And then how solar energy is converted. That is what I have actually made a full slide, but that need not be explained in detail. This is what is actually to waste to energy. This is the real picture, which again I have taken in our project at Rourkela, which is waste to energy biomethanization. Okay. So the biomethanization is nothing but biodegradable waste. You convert methane and you burn it. Here, what we have done is we are capturing this biodegradable waste, including cow dung, and there is a process, as you know, anaerobic process. Anaerobic process means anything which happens without the presence of oxygen. Then the oxygen is not there. So this dome, what you see, the green one, it is nothing but a dome. And there's a big tank, which is about 9-meter depth. And it is full of slurry of biodegradable waste and cow dung. And it is agitated. You can see a motor also. We have put a chain. We have modified it. It has been patented also. However, I'm not talking about that. So this is basically a anaerobic process which generates methane, and this methane in turn, I'll show you another slide where you can see this is a flow. This is a gas holder that you saw, and from the tank water is going. Then this particular outlet tank, it is a slurry separator. But let us not bother much about it. Let us go to this, the output of the gas holder. The anaerobic process is going on. As I said, in absence of oxygen, this is all water sealed. The whole dome is water sealed. It goes up and down as per the gas volume. And it goes to H2O, that is, water is filtered, and H2S, hydrogen sulfide, is filtered. Then biogas stove, you can go ahead, or you can generate really electricity. There is a generator set. That also photograph I'll show you. then we are actually, these poles and everything has been installed very shortly from there is a step-up transformer. We are generating 440 volts. 440 volt will connect it to 11 kV. Okay, 11 kV, just imagine. So that is going to happen very soon. So this is the generator, which is made of kilowatt. These are the filters. Okay, this is the real picture. And this is the grid. Poles have already been installed. And this is the transformer. From the output of the generator, this will get connected. And then it will be connected to the grid, because this particular plant generates 45 kilowatt per day. And our internal consumption, because of agitator, pumps and motors and everything, constitute about 7 kilowatt. So 45 minus 7 is equal to 38. So 38 kilowatt is surplus. That we will give into grid. Is per day. Okay. So principle of biomethanation, as I have told already, it is basically a fermentation process of bacteria, and that bacteria creates methane. And as you know, even our food articles, when you put outside, there is a smell which comes. It is nothing but methane. Okay. So this is also a mesophilic process, though I have not written here actually. So mesophilic means the temperature between 30 to 45 degree, if the microorganism or the bacteria is formed, it is called mesophilic process. In cold countries, they deliberately do some thermophilic process. Thermophilic means you go as high as 45 to 50 degree by putting some heaters, and the microorganism grow faster. So that is not needed in India, unless otherwise you are doing in a very high altitude or a temperature is very low. So gasification, solid mass, then methanization, all these things happen. And the technology is completely stirred tank. As I said, mesophilic range process, single stage, continuous. And methane is about 55 to 60%. And purity of about more than 80%. Otherwise, it will not burn, because the generator itself has to run. And the carbon dioxide is 35 to 40%, and hydrogen sulfide is only 500 ppm. Now this is the last topic that I would like to touch upon. I will not go into detail again. And this is green hydrogen. In India has announced a target of energy independence by 2047 and a net zero by 2070. Green hydrogen is expected to play a substantial role towards achieving that. So how the green hydrogen produced? The green hydrogen produced by the process of electrolysis, where the water is split into hydrogen and oxygen using electricity generated from renewable source. See, if you are generating or electrolysis process is going on through a solar, wind or hydropower, then only it is called green hydrogen. Otherwise, creating hydrogen doesn't actually mean anything, unless otherwise these are the three sources. There are various types of hydrogen, green, blue and other things. I'll just touch upon those things just to give an insight. So green hydrogen is produced by splitting water into hydrogen and oxygen using electrolysis from renewable sources like solar, wind or hydropower. This process is called electrolysis. So electrolysis, all of you know, I need not have to elaborate. I'll simply touch upon this fuel cell. The stored hydrogen is again channeled into fuel cell. Even fuel cell batteries have come, which is car also are being manufactured. What we call is this from hydrogen we are going to run the vehicle. It is only through fuel cell. Okay, hydrogen in turn will get energy, give energy to these small cells. That cell actually generate electricity, and that will actually run the vehicle. Okay, so clean and substantial, storable, that is the advantage, versatile. So this is how the green hydrogen is. This is a solar and wind. This is a grid. So here in tanker also it is being transported to various places. So green hydrogen, let us not go into green hydrogen, we'll go into some other hydrogen, solar, wind, hydrogen, forget it. let's see. Yeah, blue hydrogen. Produced by combining natural gas with carbon capture and storage to split methane and capture carbon dioxide byproduct. This process is climate neutral, but the long-term effect of storing carbon dioxide are uncertain, very difficult. What is grey hydrogen? Produced by splitting fossil fuel, primarily natural gas and coal, using electricity from fossil fuel. This is grey hydrogen, which we do not intend to do much. Yellow hydrogen, produced using electricity from nuclear power. Then turquoise hydrogen, produced by splitting methane to create solid carbon as a byproduct. What is white hydrogen? A naturally occurring from hydrogen that can be found. These all are names, that's all. So here's the disclaimer, and yeah, here I come to the end of this discussion. Any question until now? And I will just stop sharing the slide and come to the, I will, yeah. So I will, yes. Here I complete my discussion. If anybody is having any question, please ask.
Thank you, sir, for a nice presentation. I request to participants, please raise your hand or type your question in chat box so that whatever you want to ask, you can ask to sir. Any questions from participant side? Yes, Vishal Rohila.
Please.
Mr. Vishal.
Hello, sir.
Please.
Yes, you are audible.
Dr. Ramra from Tamil Nadu, sir.
I am audible.
Yes, sir. It's a nice presentation, sir.
Thank you.
Okay, thank you, sir.
Anyone?
Yeah, I'm Dr. Sridhar Rama. Can I ask question?
Sure, please.
Sir, what is the difference between green energy and clean energy?
Basically, green energy means any energy which is being created from renewable sources. Okay.
Clean. What does it mean by clean energy?
I'm coming to that. Now, this particular question, what you asked, even nuclear energy is clean energy. Okay. You got my point. It is not renewable energy, but it is clean energy. There can be a catastrophic effect with regard to the nuclear effect. That's different. But it is clean energy. The non-clean energy, if you really see,
so
it is fossil fuel.
Oh.
Yeah, please tell me.
What is about vehicle, EV, lithium battery vehicles? Is it a clean or green?
It is a basically green energy.
But EV lithium and battery manufacturing cause a lot of pollution. Mining, it is coming through mining.
Yes.
And it's 5 elements of graphite, copper, lithium. It causes a lot of pollution. The process of mining causes a lot of greenhouse effect. So
yes.
how can you consider this a green? I think it's a clean energy. I think because it's a process causing a lot of environmental damage.
See, these arguments are not argument. I should say the difference of opinion. As I showed you one slide also, in the renewable energy, whether we can really mitigate within this period or not, and what is the Glasgow summit or Paris summit when it happened, even in US, even MIT, this conflict is still going on with regard to clean energy and green energy. Okay. Some scientists, they believe, as you said rightly, that when we are mining the heavy metals, I told right from the beginning in my talk, that is how it is again disposable. How you'll dispose and all is also a difficult task. That is why what we are doing, we are trying to make it clean energy by, as I said, hydrogen. And that hydrogen will activate your fuel cell. So the new technology which is actually coming up in a big way is hydrogen, not the battery operated vehicles. And battery also, you must be knowing that there are different variety of hybrid vehicles. So hybrid vehicle is not necessarily only from this, even the CNG, CBG, compressed biogas. Compressed biogas is nothing but a clean energy. Yes. And in Indore, the largest plant which is being set up, and at 200 bar pressure, they are in container like our normal, what we burn in our household, the gas, cylinders, LPG cylinders. Similar cylinders at 200 bar are being stored, and that buses have started plying in Indore. Indore is a big example in India. Okay. So such things have already started coming. So that is where you really call it clean energy. Okay. It is clean in all manners. That means you are first converting your waste to energy to methane. Methane is, though slightly having less calorific value, it is around 2,700 to 3,000 kilocalorie per kg. Whereas if you see the mixed gas, what we generate, carbon dioxide, monoxide, and this other constituents, it is having very high calorific value. Okay. But high means it is about 4,200, not much. And the CNG also is about 8,000. So these gases are so efficient now, the CBG particularly, when you are compressing it to about 200 bar and using it as a cylinder, even buses are plying. Buses are plying. So there is a big revolution. So you have asked a very pertinent question and a good question. I am really glad and delighted about it. Thank you.
Thank you,
this
sir.
is the explanation. This is the explanation that I gave you.
Okay. Thank you, sir.
Sir, one question from audience side. Sunita Y is asking, can you tell the difference between carbon credits and carbon trading?
Yes. Carbon trading is basically when you are trading. Trading means you get some benefit out of it and then trade it for some other purpose. Suppose you are getting you are manufacturing, say for instance, steel, and you have taken the license to produce, say, 1,000 ton of carbon dioxide. Okay. But that carbon dioxide, when you really maintain that, do not exceed, then you can think of carbon credit. You got my point? So carbon credit, when you really do not consume emit 1,000, you emit actually 900. So 100 credit will be given to you. So that is the difference between carbon credit and the carbon this thing. So carbon credits, these are actually incentives which have been thought by European Union in 2005, so that people will offset deliberately the carbon emission, and they will do different industrial processes or try to minimize the whatever license, whatever they have taken, they'll reduce it, A, and B, if they are not able to reduce, at least they will reutilize that in such a manner that they will not further emit X plus delta X. They have taken a license for X, so they cannot emit X plus delta X. So X minus delta X, that minus delta X will be used in some other technology. You got my point. Am I clear?
Thank you, sir.
CR is also one of the names which has been given to
yes,
it, sir. Certified emission reduction, basically.
I request all the participants kindly switch on their video so that we can take one photograph. I request all the participants kindly switch on your video so that we can take some photographs.
Sir, I have one question, sir.
I request other
Please.
participants.
Sir, how can determine clean energy?
How can you
How can determine clean energy?
determine? No, I could not get you. I could not understand your question.
Sir, he was asking, how do you know something is clean energy?
Oh, how you know that something is clean energy? Okay.
Yeah.
The clean energy is solar energy is clean energy. Okay. Your wind energy is clean energy because anything it is from the nature you are getting it and no emission is there in from the this photovoltaic effect or anything what is happening in this process. There is no residual thing which is actually there. So that is why it is called clean energy. That means you are not emitting anything wrong to the atmosphere, neither to the landfill. So that is what is clean energy.
Something in that. We are not going to harm the atmosphere or our surroundings. We are using renewable energy and we are on zero emission for polluting air or whatever. We are harming this means we are not harming natural resources.
Now, can you repeat? You are asking me or you are corroborating
Yeah,
to me?
adding to
You are
your point.
supporting me.
Adding to your point.
Thank you. Yeah, please go ahead. Yeah, you're right. You're right.
We are having zero pollution and we are not harming to the nature or water. It means in sense of we are not harming water or air.
Yes.
That is, we are using
Absolutely correct.
Yes. Thank you.
That means neither air nor water is getting polluted by the process of your energy that you are producing.
Yes, sir. Yes, sir.
Even forest. The forest is also not getting destroyed. Because as I said, let us not forget we undermine the forest. Forest is one of the greatest sink. Carbon sink, if you see, forest as well as the sea. These are the two biggest sink which is actually capturing the carbon dioxide. So these two things should not be disturbed in any way. Now please, anything else? Or we should call it a day. It's already 9:36. I'm so much thankful that so many questions are coming. I'm really delighted about it.
Sir, we are very much thankful, sir, because as per new education policy, we must invite and we must collaborate with industry experts. So really, we are very much thankful, sir, for your insights regarding sustainability and clean energy technology. And definitely, sir, in future also, we will request you to help us regarding in these areas, sir, to enrich.
Yes.
Yes, sir.
And up in your campus itself, from the hostel,
Yes,
whatever you are generating the biodegradable waste, please
Yes,
convert it to waste to energy.
Yes, sir. Yes, sir. Yes, sir.
Don't produce electricity. You use that gas into your hostel,
Yes, sir.
stoves. The gas
Yes,
stoves.
Kitchen itself, we can, yes, sir.
Now, NIT Routledge is very seriously thinking. They have
Yes, sir.
they have floated tender also.
Yes, sir. Yes, sir.
So you can think of this,
And I'm very fortunate, sir, that today both the speakers are from NIT Rourkela, my alma mater. I am also from NIT Rourkela.
So I am so glad.
Yes, sir. So day was very wonderful, sir. Yes, sir. Any more question from participant side? So I am again thankful, Padhee sir. So
I am also thankful. I must
sir.
say two words to our enlightened audience. I always, I am really delighted, frankly speaking,
Yes, sir.
to such intellectual audience when I talk, I really get, really I feel very humble and very
Yes,
nice.
yes,
Thank
sir.
you so much. Thank you.
Yes, sir. Thank you, sir.
Thanks a lot. Thank you. Good
Dr. Murli, please
Yes, sir.
off the recording.
Recording. Yeah.
Okay, I am.
Yes, sir.